Good afternoon, students. Today we are going to learn about the Heisenberg uncertainty principle. Okay. In last lecture, we have learned about the de Broglie's wavelength, de Broglie's hypothesis that material particle has dual nature, wave nature and particle nature. And from this equation, you will get the equation for wavelength. Okay. And after that, we have learned about the relation between group velocity and phase velocity. And today's lecture we will learn about the what is uncertainty principle. Uncertainty means what? If you do not have ability to measure a particular quantity accurately, then we say that there is an uncertainty in measurement of that particular quantity. Suppose if you have to measure the position when particle is moving along this axis, okay, it is moving along x-axis, this axis is your x-axis. If it is moving along x-axis, and what happens, we unable to measure the exact position of a particle at particular instant of time. Okay, so what happens if I say that particle is at x, if I say that particle is at particular position, but what happens, it is not at that position, it is somewhere in between that range. So that is the uncertainty, or that is known as the error in measurement of position. So quantum mechanics gives that if I have to study, I have to measure the position and momentum of a particle, then I cannot determine both the quantities accurately. Okay, if I determine the position of a particle accurately, then there is uncertainty in the measurement of momentum. Or if I determine the momentum of a particle accurately, then there is uncertainty in the determination of position. Okay, so that is known as the simultaneous measurement at one time. Okay, so what is Heisenberg uncertainty principle? Heisenberg uncertainty principle said that in any simultaneous, at one time, in any simultaneous determination of which quantity? Position and momentum of a particle. If I determine position and momentum of a particle, then there is a uncertainty, and that the product of uncertainty is equal to greater than which quantity? H. H means what? Planck's constant. Okay, so that is the relation. What is the relation? The uncertainty in measurement of position and momentum. Uncertainty in measurement of momentum, that is denoted by P. Here it is denoted by del X. So their product delta X into delta P is always greater than H. Okay, if you write it more accurately, if you write it more accurately, then you can say that delta X into delta P, that is uncertainty in position and uncertainty in the measurement of momentum, is greater than equal to H cross divided by 2. Where what is H cross? H cross is your H upon 2 pi. Okay, H cross means Planck's constant divided by 2 pi. So this equation can also be written as H cross means H upon 2 pi and 2. So this is H. You can write this 1 upon 2 into, this will be simple for your understanding, 1 upon 2 into what is the value of H cross? H upon 2 pi. So that is more accurate. You can say that this is more accurate uncertainty principle, and this value we have to use to solve the problem. In solving the problem, we have to use H cross by 2. Okay, and in general statement you can write delta X into delta P is greater than equal to H. Where what is delta X? It is the fundamental error, okay, or uncertainty in measurement of position. What is delta P? It is the fundamental error or uncertainty in the measurement of momentum. So from this equation what we have learned is that At a simultaneous measurement, there is uncertainty in measurement of position and uncertainty in measurement of momentum, and there this uncertainty is always greater than h. वो जो uncertainty रहेगी वो हमेशा h से क्या रहेगी, ज़्यादा रहेगी. और more accurately उसको कैसे बताएंगे अपन? Exactly it can be said that delta x into delta p is greater than equals to h cross by 2. What is h cross? H cross is your h upon 2 pi. Okay, this is all about your uncertainty principle. Now, this uncertainty principle gives you the uncertainty in position and momentum of a particle. Okay, so what is this? Delta x into delta p is greater than equal to, I take it as a h cross by 2. Okay, where what is h? H is known as your Planck's constant. Okay, so Planck's constant, and what is the value of Planck's constant? Value of Planck's constant is 6.662. It is 626. It is 6.626 into 10 to the power minus 34 joule second. Okay, so what is the value of h cross? H cross value will be h upon 2 pi. Substitute the value of h divided by 2. What is the value of pi? Value of pi will be 3.14. If you substitute, you solve this, you get the value of h cross. Okay, so this is about the uncertainty principle, which is in terms of position and momentum. But uncertainty principle can be explained in terms of another variable quantities. Like you can explain it in terms of energy and time also. Okay, in terms of energy and time, you can explain it delta E into delta T. Same relation. Uncertainty in measurement of energy and uncertainty in the measurement of time is always greater than equals to h cross by 2. Or this is the more accurate expression, or you can say that uncertainty in the measurement of energy and uncertainty in the measurement of time and their product is always greater than equals to h. This is the general statement and this is the more accurate statement for uncertainty principle. This is the relation for energy and time, and this is the relation in terms of position and time. Okay, similarly, there is two another variable quantities that we use in the uncertainty principle. That quantities are angular momentum. What is the symbol for angular momentum? Angular momentum is denoted by L, and angular displacement. Okay, you can take angular displacement or angular position is also there. Okay, what is the symbol for angular displacement? Theta. What is the symbol for angular momentum? L. And what is the symbol for angular displacement? Theta. So how will you describe the uncertainty principle for angular momentum and angular displacement? The product of uncertainty in the angular displacement, angular momentum. This is delta A is the uncertainty in measurement of angular momentum, or it is known as the fundamental error in measurement of angular momentum, into del theta is your what? It is your uncertainty in measurement of angular displacement, or it is the fundamental error in measurement of angular displacement, and their product should be always greater than equals to h cross by 2. This is the more accurate statement. In general statement, what you can write this equation? In generally you can write it delta L into del theta is greater than equals to h. This is the general statement and this is the more accurate statement. Okay, so this is all about your uncertainty principle. This gives the uncertainty in terms of position momentum, in terms of energy and time, in terms of angular momentum and angular displacement. Now question arises in your mind that okay, we know about the uncertainties, displacement and momentum, but how the equation of energy and time come, or how the equation of angular momentum and displacement come? I will take the example for dE and dt. Okay, so let's solve this equation from the kinetic energy. Now you know that what is the expression or what is the equation for kinetic energy? Now, suppose kinetic energy is denoted by E. Okay, and what is the expression for kinetic energy? E is equals to half mass into the square of velocity, half mv square. Now, if I have to differentiate this equation or small variation, this will be equals to half mass is a constant. So m into what is the differentiation of v square? This will be twice v into delta v. So this two will get cancelled. What we will get? Delta E is equals to mass into the v into the delta v. This equation I can arrange this term that v into the m into the delta v, but mass into the velocity, this quantity is known as your delta p, that is momentum. Okay, uncertainty in momentum. So this equation can be written as delta E is equals to the v. Okay, v into delta p. Why you have write this? Since the product of mass and uncertainty in velocity, that should be equals to the uncertainty in momentum. Okay, because product of mass and velocity is known as your momentum. Now, from this equation, what is the equation for velocity? Velocity is rate of change of displacement with respect to the time. So, v is equals to uncertainty in position, uncertainty in time. If you substitute here, what we will get? We will get that delta E is equals to the delta x into delta p into delta p. Okay, so if you arrange this equation, so delta E into delta p is equals to delta x into delta p. So what we learn from this equation is that the product of position and momentum is equals to the product of energy and time. So the uncertainty in principle applicable for position and momentum, same it is equation can be applicable for energy and time. Okay, so from this equation I can say that if delta x into delta p as product of uncertainty is greater than h by 2, then I can say that delta e into delta t also, their uncertainty is also greater than h cross divided by 2. Remember here h cross, in general statement you can take it h. Okay, so this is all about your uncertainty principle, and why this uncertainty arises due to the wave nature of a particle. Particle has a wave nature. So wave nature means the particles are propagated in the form of wave packet. And what is the velocity of wave packet? It's the group velocity. So if you have to determine the position of a particle, you have to define the position of a wave packet. And if the position, suppose this one is your wave packet. Okay, so here there are number of waves. Okay, so you cannot define the exact position here in wave packet. This uncertainty of the wave packet give rise to the your uncertainty principle. So why it is arises? Because the wave nature of a particle. So this is all about your uncertainty principle. Okay, and in the next lecture I am going to tell you some of the problems related to the uncertainty principle, and this is to be explained by the which experiment? Heisenberg gamma ray microscope experiment, that I am going to discuss in the next lecture. Okay, thank you.